All right, so the first question says a projectile is launched horizontally at a speed of 30 meters per second. Okay, so launched horizontally, speed of 30 meters per second from a platform located at vertical distance h above the ground. The projectile strikes the ground after time t at a horizontal distance d. Um, from the base of the path, neglect friction. So it says, number 37, on the diagram above, sketch the theoretical path of projectile. We know that all projectiles take the shape of a parabola, but here you're actually going to have half a parabola, right? So you're going to make something that's a little arched like that. As long as you can justify that it's not something that's just a straight slant, that's fine. So I'll redraw it one more time. Okay. If we were to have an angle at a launch projectile, if we were at an angle, a projectile that was launched at some angle, right, you would have the full parabola here. Okay. So again, just keep that in mind. So then number 38, calculate the horizontal distance d, which we call the range, if the projectile's time of flight is 2.5 seconds. So if you recall, I used to make you guys do your givens and your unknowns in the following chart. I used to make you do an XY chart. So let's go ahead and fill that information out. You know that VYI at the top is going to be 0 meters per second because there is no vertical velocity. You know that the acceleration is going to be negative 9.81 meters per second squared in the vertical direction. You do not know this distance yet, or excuse me, they label it height. So like, let me stay consistent. So H, which we could call dy. We don't know what that is yet. We don't know our final velocity. We do know that the time of flight, excuse me, is 2.5 seconds. Because you have a half parabola, that 2.5 seconds is going to work for both the x and the y. Okay, so I could also put it here, 2.5 seconds. We know that my vertical x velocity, my horizontal initial velocity is 30 meters per second, and they want us to find dx, which we call the range, okay? So now, if we think of equations, we should go to page 6 of our reference table under mechanics, and we would find the formula v equals d over t. Obviously, for us, we're talking about vx equals dx over t. That just specifies that we're talking about the horizontal distance. So my velocity is 30 meters per second. Don't forget to put in your units. The distance is what we don't know. Time is 2.5 seconds. Put this over 1 to make it a ratio. From here, all you have to do is cross multiply. So then you have dx times 1, which is just dx. And then you do, in your calculator, 30 times 2.5, which gives you an answer of 75 meters. Okay? That's how you'd solve for this projectile, or horizontal projectile. Okay, keyword, horizontal. There was no angle theta given here, so we couldn't do the other type of projectile. Okay? Number 44. A vector makes an angle theta with the horizontal. The horizontal and vertical components of the vector will be equal in magnitude if the angle is what? 30 degrees, 45 degrees, 60 degrees, 90 degrees. So the best way for you to do this, if you remember, in your reference table on page 6, you have these formulas. AX equals A cosine theta, and AY equals A sine theta. Okay? So what I recommend you do here, just in case you don't know, just plug in numbers. So I'm going to do this one first. So I'm going to say that 5 cosine 30, and then I'll do 5 sine of 30. Okay, let's just see what happens. So 5 cosine 30, I get 4.33. Okay, so I'm going to write that over here. 30 degrees is 4.3. 5 sine of 30 is 2.5. So that answer is not good. They're not equal to each other. So let's try 45. So again, I'm going to do 5 cosine of 45 and 5 sine of 45. Okay, so 5 cosine 45, I got 3.54. And then, let's see, 5 sine of 45, I got 3.54. So that looks like a pretty good answer. So I'm going to put a dot next to it. But let's check out the other ones just to verify. 60 degrees. So again, 5 cosine 60. 5 sine 60. So 5 cos 60, I get 2.5. 5 sine 60, I get 4.33. Notice it's actually the reverse of the 30 degrees, so that's not good. So I can get rid of answer 3. So now let's try 90. So I have 5 cos 90 and 5 sine of 90. So 5 cos 90, that is 0, and 5 sine of 90, which should be 5. So here we see that choice 4 doesn't work, so therefore choice 2 is the answer. So 45 degrees is actually halfway, the halfway point of 90 degrees, which is why your components are going to end up to be the same value. Okay, so this is the next question. Give me 1 second. A kicked soccer ball has an initial velocity, okay, so it's an initial velocity of 25 meters per second at an angle of 40 degrees above the horizontal, level ground, neglect friction. 14, calculate the magnitude of the vertical component of the ball's initial velocity. Okay, really important here. They gave you an initial velocity and they gave you an angle. So we have a launched projectile at an angle. Okay, that's really important. Okay. So let's write what we're given. So, oh my goodness, sorry. And I apologize for the coughing. I know it's kind of not the best, but it is what it is. 25 meters per second. Theta is 40 degrees. My unknown, they want to find VYI. Okay? So if you go in your reference table, you need to find something that has some sort of vector quantity and an angle. And what we say is AY equals A sine theta, or VY equals VI sine theta. Whichever one you want to write, that's totally appropriate. Either one will be accepted. So then you just substitute. Remember, you want to keep your units in there. So I'm going to put VY equals 25 meters per second times the sine of 40 degrees. Again, your calculator should be in degrees. If it's not, your answer is definitely going to be wrong. You do not want it to be in radians. So 25 times the sine of 40, and you get an answer of 16.1 meters per second. Okay? Again, this Regents is not going to be asking you to round in a particular spot, so you'll be okay. Number 15. Calculate the maximum height of the bullet reaches above its initial position. Okay? I know we don't really have a lot of space here, so I'm kind of squeezing it in over here. Yeah, number 16. If you remember, we used the an XY T-chart. So we don't really need to know any of the X information because vertical height, or height is vertical. So that's kind of what we're looking for, dy. We know that the acceleration is always going to be negative 9.81 meters per second squared in the vertical direction. My initial velocity vertically is 16.1 meters per second. Keep in mind that when a projectile is launched, right, at this halfway point right here, this vertical velocity is going to be 0 meters per second. So really, what we have to do is just look at half the path, because what we're doing is we're going from the start all the way to this point. So really, we only need to focus on that, and we do have a VYI, so technically we can consider that our final velocity. Okay, so our VF is 0 meters per second, and time we don't really care about. And actually, I'm going to get rid of that question mark. So now let's see if we can find an equation. So again, you're going to be on page 6, the mechanics section. You're going to look at our kinematics formulas, and you want something with a D, A, VI, and VF. So that formula looks like the following: VF squared equals VI squared plus 2AD. Okay, and you're just going to substitute. That's pretty much it. So VF squared is going to be 0 meters per second squared equals 16.1 meters per second squared. And hold on, we want to make sure that that square is definitely outside the parentheses, because you're not squaring the units, you're squaring the actual number itself. Okay, plus 2, you are going to put a negative 9.81 meters per second squared here, and then you're going to put d. Notice here that you have meters per second squared, indicating that your units are squared, not the number 9.81. Okay, let's clean this up. 0 squared is still going to be 0. So now let's do 16.1 squared. That's 259.21 plus, and actually I'm going to clean this up too. So we're going to do 2 times negative 9.81, and that should give you negative, oops, let me go back to the pen, negative 19.62d. Okay, now it's just your basic algebraic kind of question here. So you're going to subtract, because you're going to do inverse operations of the thing that does not have the variable attached to it. So 259.21. So again, that's just 259.21 equals negative 19.62d. To get rid of this multiplication, the thing that's holding the negative 19.62d together, you are going to divide by negative 19.62. Okay, and that leaves d by itself. So you're going to divide 19.62. And the answer that you should get once you do this in the calculator, so 259.21 divided by negative 19.62 is 13.2 meters. And if you think about it, if you're finding a height, your height is not going to be negative because it's a distance. They're not checking the displacement. They want to know the distance. Okay, so keep that in mind. And I know number 16 is covered up, but it did say, you know, hey, can you identify the path this object takes? Any projectile is going to have a parabolic shape. So something that I drew to the left of you, like right here, that's the shape of the whole path, the whole thing. We care about the whole parabola, not just half, because we are being launched at some sort of angle from the ground. Okay? So just keep that in mind.